So yeah, I'm also pretty excited about context receivers, so that's why I like talking about this. Yeah, it's like you know, it's so cool, but it's also going to like end all the battles about DI frameworks. I think so. It's like like they should give them like a peace prize, something in The Hague. But yeah, this context receiver, just to give you an idea, is this new Kotlin feature, and I will describe a lot of things about this. Actually, it's like the coolest feature in 1.6.20 and 1.7 and all of that. And well, unfortunately, it's still experimental, so in theory, you shouldn't use it in production, and I think you cannot use it in Kotlin native and multi-platform. But it actually covers a lot of use cases, mostly for all these cross-cutting concerns in your software. So I will go through a few use cases of how you can use context receiver from what you should be using it for, like dependency injection, to what you should use it for if you're a crazy scientist, like error scopes and do type classes and things like this. So that's mostly to show how powerful this kind of thing can be, and also to show you a possibility of how Kotlin code can use in the future. Maybe try to figure out together whether this is how we want Kotlin code to look like, or maybe this is just some crazy ideas in my mind. Who knows? Anyway, as an example, I will use logging, which is this prime example of what we tend to call a cross-cutting concern, and that's something which has to happen in your code, right? But it's never part of the main domain, like unless you are building like a logging application. But most of us are not building these kind of things. But you still have the logger, so it's not part of your domain. You actually don't want to be super explicit about it, because then it will pollute all the code around it, right? It's like it has to be there, but you would like to hide it as much as possible because it's not part of your business logic. And actually, logging is something that somebody writes in a library and you reuse in a bunch of different other applications or domains. So this is, as I said, something, and you can think of logging, I don't know, instrumentation, a bunch of those things usually are like cross-cutting. So in this case, I will model this quite simply, just an interface with a function log, and it has a bunch of stuff, exactly the 3 arguments I need you to show my examples, which are like the log level, the subject, and the message. And if you want later on lunch, we can talk about why I put the suspend there. I mostly, every time I do something which may involve input, output in some place, I just like to put the suspend, because usually you end up wanting it suspend at some point. So, but that's a different thing. So, how would you use context receivers to do dependency injection of your logger interface? So, the first thing you do is you add this to the signature of the function where you are using. So, we have this download data function, and at some point we will like to log things. Because it's doing whatever. So we add this context logger before the whole thing. You can add this. I put it on top to like showcase it's a context, but it's like a very long signature. So it's actually like context logger suspend fun. It's all like one big thing. So that's the first step. And then magically the interface, so the logger, is available in the body of the function. As you can see here, I'm calling log. And this log is not coming from any extension, because there is no extension receiver. It's not coming from the surrounding class, because there is no surrounding class. It's actually coming from the context. It's something I'm calling from logger. And I will shortly go later on how it actually works, that you can actually call log inside of it. But that's the idea. Whatever is in the context is now available in your body. And the nice thing is that now you can call other functions which use the logger. So in this initialized app, I'm using my download data, which, as I showed, uses the logger. Let's assume there is also like a download avatar, which also uses the logger. And as you can see, I just declare that my initialized application uses the logger and then nothing else. So if I'm not using the logger at all, this is completely hidden. except for this one point, which is the signature of my function, where I declare this should be using the logger. The rest is kind of hidden away. And the last part is at some point, you need to provide this logger, right? I mean, until now, you are declaring that you depend on this interface. But you can use this with function. And the fact that it's a function is something quite interesting. We will delve into that later. But with this function, what you do is you bring this console logger into a scope. And within the block, now you have whatever was on a scope plus a logger, which means that now you can call initialize app, because the logger is, let's say, it's in the context. If you didn't have the with, by the way, you will have an error saying there is a missing logger in the context, so I cannot call this function, which I also find like a nice error, right? It's like telling you exactly what you are missing. So those are the pieces to use context receivers. So you declare them in the function. If you have in the body, you use it as it was part of of their scope. Then if you are not using it, you don't see it except for in the signature, and then you use with to inject the thing, usually like at the top level of your application or whatever. So this point is maybe interesting, and especially because we are in an Advanced Kotlin conference, kind to figure out what is this when we are using context receiver, because this gets a bit hairy. So imagine we have this function. So we have this, we are defining it inside a database class. It has a context, and we have this function, which is an extension on user, but also has a logger in the context. So that means that in order to use this function, we need to be in the context of a database, and have a logger in the context, and then we have to call save on a user. So we need all of these things to be present. So this corresponds to the 3 different kinds of receiver. That's how they call it in the Kotlin documentation. So the fact that you are inside the class is what they call the dispatch receiver. So that's where you know that this has database. Then you have the context, which you can have more than one, by the way. So this is also part of it. And then you also have the extension receiver. So maybe if you have done some weird stuff, you may have come with an error with this AND symbol. That's how Kotlin essentially represents that this has a special type, which is the combination, actually the intersection of these 3 things. It is a database, this is a database and logger and user, which means that when you write this dot, you can actually call anything on database, logger, and user. And hopefully, nobody has the same method with the same name, so everything can be resolved automatically, and it's like everything works magically. But what is actually happening is that this has this special type, and from this, the compiler can actually tell what are the methods available there. You can, if you need, you can actually refer to one specifically by having this at type thing. So this, if I write this at logger, that means I want to only see like the logger facet of the this. So it's, in this case, it will mean I'm accessing the logger in the context. If I write this at database, I'm going to the dispatcher and so on. Cool, so just to remind you, yeah, so we have all these things, dispatch receiver, that's where the method is declare, extension, when you use type, like type dot declaring a function, that means then you can call it with dot, and then you have context receiver, which is the new thing. It is a bit like extensions on asteroids, because you have more things coming inside. What you lose is that you cannot use the dot. You need to explicitly call the values with. So you need to have with blah, 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 and then you can call the function, whereas with an extension, you can just use the thing dot method. Cool, so what can we do with this? So I already mentioned a bit about dependency injection. So that's like the basic use, and if you read anything about context receiver, that's what most people use it for. So imagine we have here some logging code. It doesn't really matter that much. The main thing is that I'm logging stuff here. So you see the log there. and I'm kind of doing a HTTP post request. Whoa, whoa. I did this with this. And then, okay, so we are doing an HTTP post request. So that means that we have two dependencies in this code. We have the logger, but also we have some kind of HTTP service, or whatever way we are doing this, coming from the HTTP post. So you can see there that one nice thing about context receiver is that these two things compose. You can actually say you need these two things in the context. And then we can play a bit with these two basic rules. So the context declares all the services you require, and with allows you to inject the values. So just by following these two rules, you kind of can do everything dependency injection can do, but a nice, more type safe, and I would say better somehow. So the first thing is because I have the context being part of the signature, that means that a lot of things which usually happen maybe if you are using dependency injection framework at runtime, something will fail at runtime. You have others like coin, which happen at compile time, but it's still later in the process. With this, the compiler knows about this because it's part of the language, which means you can check your usage. Hopefully, the JetBrains people will introduce things in the IDE to do this. And what I think is nicer is that you are very explicit about what you actually need. It's part of the documentation of your functions. This becomes something that the team can share, can know directly on the docs what's happening there. Another interesting thing is that you can actually build things which depend on other contexts. So for example, we can say that the particular implementation of our HTTP service, which actually goes to the network, depends on the logger, because it's doing some logging inside. So you can declare this, and actually there is a trick. This context is not only available on functions, you can also declare this in a class. And that essentially means that when you call the constructor, you need to provide the context, and inside the class, the context is also available. So it's like for the entire class, you need this thing. You need this to build the class. And this, essentially what it's doing is imposing an ordering in which you have to inject your things. Because in order to create the network HTTP service, you need a logger. That means you first need to create the logger, and then put it in the context, and not only then you can call the with, or you can only call the constructor of the network HTTP service. So essentially, this is like a compile time check for ordering. So when you end up having all these complicated graphs of hopefully not graphs, like trees of dependencies, these checks at compile time that you are doing it correctly, because otherwise their code doesn't compile. And even better, because this with is just regular Kotlin, and some other patterns are kind of easy to achieve too. So for example, imagine we are running some tests and we want to create a mock. Well, in this way, it's quite easy because you just implement your service in some other way, like like a network service which always fails because I want to test the non-happy path of my program. Then you can do this, and then you just say, with always fails, and then you run your test here. Just regular Kotlin, you're injecting what you want without any hassle. You can also combine the fact that you can get the context and change and use with to change it a bit. For example, imagine that we, at some part in our code, we don't want to have so many login, because somebody wrote the other library and included 10,000 million logs things, but we don't really care about that part. So we want to say in this tiny block or big block, we only care about the critical errors which are logged. So what we can do is create a new logger which wraps the other logger. That's what I'm doing here in the class. And then I'm overriding log in such a way that we say, if it's info or warning, I don't care, just do nothing. Otherwise, just call the underlying logger. And maybe it's only left is critical errors or whatever. Just imagine the idea. But the good thing is now we can just use our regular logger for the important stuff. And then for this part, which we don't really care, we only care about the critical things, we use with. We take the logger we have in the context, wrap it with the only important logger, and use with, which means that in this part, a different logger is being injected, which only, which overrides and only does what we actually care about. So that's, we are combining these two things to get a nice pattern here. And another thing we can easily do using this is we can also easily combine this kind of services into one single module, and then, just pass all of them at once by wrapping this in the module. And we can actually use delegation to have nicer syntax. So what we are saying here is that app module is actually a logger, and we are delegating to the logger field. So it's like this implements the two things. And you use DI frameworks, you have sometimes this module thing with just combined services, because when you have 10 of them, you don't want to create all of them by hand. Cool, nice. So what's the next thing you can do? You can actually, so that's already great. We don't need DI frameworks anymore. There's something which goes built into the language. So in the same way that we have suspend and we don't have to care about the flat maps in the futures and all these kind of things. I like having things in my language. Well, but type classes. So let me introduce the problem a bit. So if you've done any Java programming, you may know about this comparable class. I think it's the same in Kotlin too. But anyway, it's this interface in which you have this compare to, and then you compare to object, and then you get an integer, and if it's greater than 0, that means that the first one is greater than the other one, and so on. So we have this interface and allows us to write code like this. Now, this actually is a bit problematic, because you can only implement interfaces if you actually control the code which implements the interface. You cannot go there and just shoehorn another interface. And it has another problem. What about comparing things in different ways? Now, we can solve this with context receivers. What we do is instead put the comparable as part of the context there. So now it doesn't come sort of as part of the T. It comes as an additional part of the context. And now imagine that we are implementing a new serialization format, and as I said, nobody implemented it for Booleans, or we want to override this in some other way. Well, we can now do this because we can say, look, here is how I want my pretty of Boolean to look like. I just have this interface as a different object, and then using with, I put it in the context. So instead of being part of the Boolean class, now it's part of a context that has to be provided in order to run this whole thing. Now you will, of course, say, yeah, but now I have to provide all this with all this thing. That's terrible. And that's why languages which actually have this pattern in the language, like Haskell and Scala, have special syntax, but the Arrow developers are working on something where you just say provider, and then it essentially writes the with for you, so you don't have to do this. So that's one of the things maybe in the future will be useful. Who knows? Anyway, as I said, this is one problem, because now we can inject the pretty of Boolean even if we don't control Boolean, which we don't, because somebody wrote it in the standard library. But what if we want to sort, and this is actually coming from Kotlin standard library, you want to sort the list, but this has to be comparable. But what if I want to sort backwards of using a different key? We cannot do this because the comparable is one per type, because it's extending the interface. So what happens in the library is that you actually have a different function called sort with, which takes a comparator, which is how you want to compare things. Oh, wow. I don't know how I did that. This is all very weird. So it actually, you have to duplicate the function, but the function looks pretty much as the interface I was showing before. So actually, if we instead use a context receiver here, that will be much nicer, because if it's in the context, we don't have to pass it around in our comparators. But now we can define things like this wrapper thing I mentioned, like this reverse wrapper, which takes a comparable and just creates something which compares it in the other direction. So it takes a comparable in the context, T, it has to exist, and then it's just make it go the other way around. And now if I want to compare, I want to sort the list in reverse order, I just inject a different comparable. I say with reverse, and that creates a new comparable, which goes in the other direction. Oh, it's wrong, yeah. Is it wrong? Yeah. Maybe it's the other one, who knows. This sort is the same sort, but we are overriding the comparison here. Cool, so that's great. That's a way useful for adjectives, as I said, like comparable and serializable. But let's go to the last crazy thing, and I have to go through this because Urs said somebody has to use the word effects, so I'm one of the people who will use them. So, yeah, in Kotlin you have these two ways to handle errors, right? You have exceptions, which are untyped, but it has good things. If you are not handling them, you write no code. Things just magically bubble. And it has a special syntax, like try and catch, so you clearly show what's happening. Now, the other possibility is to use things like result or nullable types, which are more explicit. You declare them, but then you have to write boilerplates and maps and flat maps or whens and things like this. So what if we could have the best of both worlds, right? Like exceptions. So if you are not handling them, then you don't see them, but they are still explicitly typed. Does it ring a bell? Yeah, we can do this with context receivers by having, that's actually part of Arrow. I don't know if it's going to come. I think it's already in the library, or maybe in the new release it will come. So we can put this thing on the context called race, and that's like a special type who only Simon knows how it works. So ask him. So you put it on the context, and it's like you are declaring, this now can raise this error. This is like a checked exception. But if you are not using it, if you are not catching the exception, you don't see them. So you can just say, read all the files. Each read file can throw a file error thing, but, it's not there. You just use your regular map. So in that sense, it's like an exception. You don't see them if you don't handle them. But it's nice in that you are explicitly typing this. So, you can actually have your own errors. So these don't have to be exception, which is also a nice thing. You can have your own error hierarchy, and then just say, I'm going to raise this special file error, and you just, instead of throw, use raise, which is the name we came up with, because you can use throw, because it's a keyword. But that's kind of the idea. And again, once you have this, you can just kind of run it. You use this effect thing, which essentially will give you back like a nullable or an either or whatever type you want to get, or a result back, and then you can just handle them. So if you are handling them, then of course you have to be explicit about this because you are handling this. Now we actually have nice things called catch and so on. So this is a bit older, but it's getting better. We are working on a nice API following this design idea. Anyway, just to end, once you start seeing context, you see them everywhere. What about the launch in the coroutine scope? Like, this is something in the library. Well, this actually uses extension function, but we could also make them like a context function, right? Because it doesn't have to be exactly the extension. We just need like the capability of being able to launch new things. So it's like coroutine scope is actually providing a service or an effect. It's like declaring one extra thing you can do within your block. It's a special service, which in this case is creation of concurrent jobs. So once you go this, you start seeing effects everywhere. You can say, oh, actually, my read configuration file uses some kind of jobs of some thread management, so I need a coroutine scope in my context. It may also fail, so I need a raise file error in my context. And by the way, it reads the file system, so I'm going to also introduce a new file system service for this. So once you start looking at this, it's like everything just becomes things in the context, and you can be very precise about this. So before Simon just throws me out of the stage, context receivers are awesome. You can use this for everything. I mean, dependency injection is what they are thought for, but as I said, you can use this to provide extensibility in many different ways, and also to have the good things of exceptions with the good things of type errors in one go. Been a pleasure.